Okay, in this video, we're going to study this sequence and we're going to find its limit. So our sequence is defined by the following manner. So V0 is 0 and Vn plus 1 is the square root of 12 plus Vn. The first thing that we're going to do is we're going to prove that Vn is less than 4 for all n. In this case, we include the 0. Okay. Next, we're going to prove that 4 minus Vn plus 1 is less than 4 minus Vn over 4. And after that, we're going to find the limit. Okay. So the first thing that we're going to do here is we're going to prove that Vn is less than 4. So basically here, what we can do is we're going to use the principle of mathematical induction. Okay. So we're going to prove that. So first we have that V0 is 0. It's less than 4. Okay, 0 is less than 4. So this is true for V0. So we assume that Vn is less than 4. Okay, and we're going to prove that Vn plus 1 is less than 4. So we start from here and we arrive here. So we have this one as a given, a premise, okay? So Vn is less than 4. So if we add 12 to both sides, we're going to have 12 plus Vn is less than 4 plus 12, which is 16, okay? We take the square root. 12 plus Vn is less than 4. And this is just Vn plus 1. This means that we proved that Vn plus 1 is less than 4. Therefore, according to the principle of mathematical induction, we have Vn is less than 4 for all n in n. Okay? The next thing that we're going to do is we're going to prove this result here. Okay? So this is just simple algebra. So we have 4 minus Vn plus 1. It's going to give us 4 minus the square root of 12 plus Vn. Okay? We're going to use the conjugate. So we have 4 minus square root of 12 plus Vn. We're going to multiply it by 4 plus the square root of 12 plus Vn. And we divide by 4 plus the square root of 12 plus Vn. Okay. So here, using algebra, we have 16 minus 12 minus Vn over 4 plus square root of 12 plus Vn, which is 4 minus Vn over 4 plus square root of 12 plus Vn. And this one is always less than 1 over 4. Therefore, we have 4 minus Vn less 4 minus Vn over 4. So this proves that we have 4 minus Vn plus 1 is less than 4 minus Vn over 4. Okay, and that's what we have to prove in this case. Next, we're going to use this one to find the limit. How can we use this one? So we have this one true for all n. Okay, so this is for all n. Okay, so let's take the absolute value for both sides. Okay, so we have Vn plus 1 minus 4 in absolute value is less than 1 over 4, 4 minus Vn. But we're going to use this one recursively here. So it's less than 1 over 4 times 1 over 4, which is 1 over 4 squared, times 4 minus Vn minus 1. And etc. We keep multiplying. So we have 1 over 4 times n, 4 minus V0. And V0 is just 0, okay? So in this case, we have, so we started Vn, so we started from Vn, and we arrived at Vn plus 1. That means we did n plus 1. So we have n plus 1. So here, Vn plus 1 minus 4 less than 1 over 4 n plus 1, okay, times 4. But when we divide by this 4, we get this one is 1 over 4 to the power n. Okay, so here we have this one less Vn plus 1 minus 4 less than 1 over 4 to the power n. Okay, now we take the limit. Okay, so we're taking the limit. So we have the limit here. So gives us that this one is 0. Therefore, the limit of Vn plus 1 is 4. Okay, and therefore the limit of Vn is 4. Okay, there is another way that we can do to solve this kind of questions. Okay, we can get, or we can see that without doing all this. So we can see that we can define a function as f of x equals the square root of 4 plus x. This function is 12 plus x, not 4. So this function is continuous. Okay, and we define Vn plus 1 as f of Vn. Okay, so this one is continuous. So we have, when we have the limit, and we assume that this limit exists, so therefore the limit of Vn plus 1, which is we call L, so L is going to be f of the limit of Vn. Because f is continuous, we can enter the limit here. So this one is going to be f of L. So now we solve this equation. So it's going to be f of L is just square root of 12 plus L. But L is positive because this one is positive. Because defined for minus 12 plus x positive. So here we solve, we get L squared minus 12 minus L equals 0. When we solve, we get L is 4 or L is minus 3. Since it can't have two limits, it has only one. It has either this one or this one. This one to be rejected, it's negative. This one is to be accepted. So L is 4, the positive limit. Okay? And this ends our video. This is a great way to solve in this kind of questions without going through all this. But this is helpful because we do the algebra and we remember everything that we can remember. Okay, from the conjugate to the limit of a geometric sequence. Okay, thank you very much. If you have any questions, you see any mistakes, please comment and subscribe and share.